a new way to probe the dark processes in the universe. Because every time we make the observatories more sensitive, we can sense gravitational wave signals from further away, from farther out in the universe, from further back in cosmic history. Things like supermassive black holes spiralling in to collide, small black holes orbiting round supermassive black holes, tracing out the dents in space-time of those supermassive objects. A long-term goal is to probe back further towards what we think of as the Big Bang, the earliest moments that we understand of the universe as we know it.
If you think about it, time and time again in the history of science, unlocking the mysteries of gravity have led to a deeper understanding of the universe. Galileo and his ramp, Newton and his apple, Einstein and the falling man in the lift. Each of these characters challenged the scientific consensus of the day. And even today, understanding the true nature of gravity remains one of the biggest challenges in science.
Which brings me back to the smartphone app. And it's at this point that our story, for me at least, takes a completely unexpected turn. Unfortunately, it's all gone a bit pear-shaped.
Okay, so here's what's happened. A couple of months ago, we launched the app, and it was all going really well. Thousands of people downloaded it and have been sending us their results. We've been collecting the data to create this nationwide map to show how time flows at different rates for different people around the country. Unfortunately, I've just realized there's a big problem. You see, I was going over the scientific literature and I came across this subtle point about relativity which basically made me sit bolt upright. There was this horrible, dawning realization that I've made a mistake in the equations that get fed into the app.
So what this means is all the results we've been gathering are wrong.
The issue lies in the strange and subtle effects of Einstein's theories of relativity, and it's fundamental to the way time flows across the surface of the globe. Now, what if I use my smartphone app where I live here on the south coast of England, and then go and spend a few days down near the equator, say here on the west coast of Africa?
Now, we know from the road trip that gravity is weaker by the equator. So that means time ticks faster there.
But there's another important factor we have to take into account: movement. You see, when I'm here near the equator, I'm moving more quickly than I was back in Britain because of the rotation of the Earth.
Einstein says movement slows down time, so clocks will tick slower at the equator.
This is where the error crept in. You see, I had taken into account these two effects, but I'd missed a crucial point. They cancel each other out exactly. In fact, the Earth bulges out exactly the right amount for its rotational speed to make sure they cancel out. So all clocks on the surface of the Earth at sea level tick at exactly the same rate.
So now I'm having to go right back to square one and completely rewrite the equations for the app. And to test if it's working, I'm going to use it over the course of a normal working week.
This is where I live. This is Portsmouth, which means I'm very close to sea level. And this is how I start most mornings, catching the train to work.
The app records my speed as I'm on the train and calculates how this slows down my personal clock.
But I think the train journey should have slowed my time down by a few trillionths of a second.
I'm heading for the BBC's headquarters in central London, and gravity should be a bit weaker here.
I'm a few meters above sea level, I guess, here, and so there'll be a speed up of my time because of altitude.
The app compares the way my time flows with a stationary clock at sea level. So what's my result? On an average day, my movement makes me age slower by 1/3 of a nanosecond. That's 1/3 of a billionth of a second. But the weaker gravity I'm in means I age faster. Overall, 1/2 a nanosecond faster. I've also given the app to some other volunteers to compare how they age over an average day. Nick flies cargo planes. He flies from Chicago to Germany.
Tomorrow morning, we have to leave to go first to Milan and then on to Tokyo.
His travel slows down his aging, but much weaker gravity at high altitude speeds his clock up by just a bit more. Overall, he's aging 5 nanoseconds faster than a stationary clock at sea level. Vanessa runs a pub in the Yorkshire Dales.
I'm going to take you outside to see the weather conditions here. So here we are outside the Tan Hill Inn. We live right in the middle of the National Park on the moor.
The Tan Hill Inn is famous as Britain's highest altitude pub, at over 500 metres above sea level.
We don't have any neighbours. We just have sheep.
Her altitude means she ages faster every day by around 4 nanoseconds, compared to someone at sea level. There's Kevin, a mountaineer in the Highlands.
I'm on a mountain in Glencoe called Scornahulia. I've been at an altitude generally of between 2,000 to 3,000 feet for a lot of the day. Throughout the day, I've just been logging onto the phone, logging onto the app, and just checking it out and having a look, and I've been watching it get bigger, watching the value get bigger and bigger, so it's been quite a lot of fun.
On an average day of climbing, Kevin's personal clock goes faster by 1 nanosecond. Gary works for a Scottish water retailer.
My job takes me all over the UK, dealing with energy consultants and energy brokers. As far up north as Inverness, as far down south as London. Approximately do about 1,000 miles a week, sometimes more, depending on the number of meetings I have.
Gary's car journeys do slow his time down a bit, but being above sea level means he still ages faster by 3/4 of a nanosecond. Our final volunteer is Walter. He lives close to sea level at the iconic John O'Groats.
I run a tourism business and I started about 50 years ago. So when people come here, they can actually physically speak to someone who's been born in John O'Groats, and if they ask questions, I can tell them all sorts of useless information because I'm full of useless information.
So our final results show that if you want to age more slowly, try to live near sea level, like Walter. Or there is another way to do it. Get a job on the International Space Station. Its 17,000-mile-an-hour orbit will give you a boost.
We did the math for the astronauts. Every month, you are about 1 millisecond younger. So, 1,000th of a second. So after 6 months, you are that much younger than people on Earth. So I'm younger than I should be. I hope I look it.
Of course, for us on Earth, time dilation is so utterly minuscule, a few billionths of a second between us, you might think it's too frivolous to even bother about. And yet, in the long and difficult process of designing the app, I've come to an extraordinary conclusion. The different ways that time flows may not be some quirky byproduct of gravity. It may actually be gravity. It may be the cause of gravity, the reason why objects fall.
One of the colleagues I've been consulting is Kip Thorne. He's one of the world's leading theoretical physicists and a driving force behind the creation of LIGO. While I was going back over some of the basic physics behind the app, I came across an intriguing idea of his. It's a very interesting and different way of describing gravity.
This is what Kip says. Everything likes to live where it'll age the most slowly, and gravity pulls it there. Kip's based at Caltech in California and is one of the most respected theoretical physicists in the world.
Firstly, Kip, a serious thank you for helping out with the debacle over the app.
Well, I sympathize. I've made so many errors in my own over the years that I am totally sympathetic.
One of the things that struck me thinking about this is something you wrote, Kip. You said, everything likes to live where it'll age the most slowly, and gravity pulls it there. Was this a way of explaining something that you felt was a neat explanation, or is there something deeply profound about that?
I think there is something deeply profound in some sense, but it's a lovely description of Einstein's first major insight about gravity in 1912. He realized that gravity that we feel on Earth is due to a slowing of time on Earth.
So time comes before gravity in that sense. You know, on the Earth's surface, time runs more slowly, and that accounts for why gravity wants to keep us there.
Well, I think in a very deep sense this is true. Objects want to fall, that the flow of time, or the rate of flow of time, is the thing that produces the gravity. It is the thing that is ultimately responsible for the fall.
So somehow it's in the nature of all objects to move towards a region where time runs slower. Kip's formulation works anywhere in the universe where the gravitational field is such as on Earth.
The difference in the rate of flow of time is tiny. At high altitude and on the surface of the Earth, the difference in the rate of flow of time is 1 second in 100 years. That's not very much. But that is enough. That is precisely the right amount to produce the gravitational pull that we feel and produce the accelerations we're talking about.
Wow. Okay, I need to go and write this one down.
So my investigation deep into the weird ways of gravity has finally left me face to face with one of the greatest mysteries in all of physics. The nature of time itself.
It sounds like such a simple question. Why does the apple fall? And yet hundreds of years of scientific inquiry investigating this single action have led us to completely redefine the way we think about the very nature of space and time. And now I've been presented with this extraordinary proposition that somehow, in some profound way, the apple falls because it's seeking out the place where time runs the slowest. So does gravity dictate the flow of time, or does time itself define gravity? Could this hint to fundamental new laws of physics as yet undiscovered? I think I'm going to have to think about this a bit more.